Good night. We need to get talking about electric vehicles, and this will just get the subject introduced. It's video number 28. I'll be devoting all of 28 series to electric vehicles. What about going electric and the idea of going electric? Well, the first thing about it is the government in Ireland is mad for it, and in many countries they're pushing it, but nowhere like Ireland. And we're always trying to punch above our weight and show the rest of the world how to do things. It works real good until it comes to housing the homeless or other providing hospital services. We're bottom of the list there, but we're top of the list when it comes to big ideas. So, in any event, one of the things about electric cars or electric vehicles is that they contain an electric motor. An electric motor is in effect a transformer. It has primary and secondary coils in the same way as a transformer has, except that they're called stator and rotor. Now, if you hold an electric motor in principle and don't let it go round and put an alternating current into it, we'd say the rotor, the stator will give an alternating current out. It works the same as a transformer. The only difference is that the motor revolves as the poles pass the stator. Now you'll get the principle of an electric motor online there, and if you want to really look at it, just go into my series, Val Martin Ireland YouTube, clips 1, 1A and 1B. I think that's it, or is it 1A, 1B, 1C? You'll see there's number 1. There's 3 videos. I think it's 1A, 1B, 1C, and they give you the principle of electricity. And if you go to the third one, 1BC, you'll see the principle of an alternating current motor and a direct current motor. It's all there, and it's perfect because it shows it working. Actually put it working, so I can't be bluffing. Now, remember, in relation to a motor, there's a thing called back EMF. Now, when you put a current into a motor, it spins. If you had no resistance in the bearings, if you could have a bearing that had no resistance and no air resistance, the motor would spin and it had used virtually no current. In fact, ideally, it had used no current at all. You could leave it spinning all night and it had used no current. Now, unfortunately, there is air resistance and there is resistance in the bearing. So even a motor with no load will spin round, but it'll take in a certain amount of current. And as it spins, it generates current. So a generator and a motor is the very same thing. They're the very same thing. Now you can make generators and motors that won't operate as each other, vice versa. But if you have everything else equal, you can put electric current into a motor, spin it round, and if you take the wires off it and it keeps spinning, it'll give a current called a back EMF. So when a motor is running using, we'll say it's using 100 watts as it's revolving. It's taking in 100 watts, but it's giving out something like maybe 90 watts. The result is it's only using 10 watts. So the power is taken in and the motor also generates, and that back EMF means that you only need 1/10 of what it would take in if you stopped it completely. Now, as you apply a load, you have less power coming back out. So the motor is taking in the full 100 watts, but it might be only given back 50, with the result is that it's using 50 watts. And if you bring it right down till you stop it, if you could stop it completely, the motor is acting as a full transformer and it can't revolve, and so what happens is there's a dead short, as it were, and it'll heat up. So all of the power going in comes out as heat, and that's why if you jam a mains electric drill, you'll burn out the coils in the electric drill. Okay, now that back EMF is very important to understand. That's how a motor uses more the bigger the load goes on. It uses the same, irrespective of the load, but when you stop it completely, there's no back EMF. So it's using the 100 watts when it's blocked. Whereas you let it run completely free with no load and no resistance and no bearings, it uses 0. So there's a scale between. That's how it works. Now, so that's dealt with in that clip 1C, and you'll get examples of it online there. I might do a working example on something. Now, technically with an electric car, if a person lived down here and went to work every day up here, or at this point here, it would take a certain power to get up, but when he'd be coming down again, he could charge up his battery. Now, technically, an electric car can feed the energy back into the battery if it's coasting, or if it's been driven by, if it's being pulled or whatever else. Now, by the way, you can't tow an electric car from start. There have been some of them wrecked by doing that. You have to be very careful. But when they're running, they're designed so they feed the power back in or take the power out of the battery. And there's no internal combustion engine. There's no petrol or diesel car that can use diesel or petrol, and then if you're going downhill, can push diesel and petrol back into the tank. That can't be done. An electric car can do that. Okay, so now one of the points about electric cars is if you want to extend the range, you have to increase the number of cells in the battery, and you have to increase its weight. And there's an optimum amount of weight. There's a point where the weight of the battery would be so enormous that it could never be practical to use it for an electric vehicle, because it would take more to carry around the weight of the battery than you'd get out of it. Now, this was the example with milk floats and other electric vehicles when there were lead acid batteries. Lead acid batteries would run a milk float round a town or somewhere locally where you had fairly level streets and all that, and deliver milk around door to door. The problem is, if you use them for lorries or anything like that, the weight of the battery to move it uphill and do all kinds of other long range things would be so heavy that it would only get you up the road a bit. So you're always caught with the weight of the battery, and you're still, with lithium ion batteries, you're still caught with the weight of the battery. So there's an optimum weight of the battery. So now, in one example I studied of electric car, the AC current comes in from the mains, it's converted into DC, direct current, that charges the battery. The battery, it's then converted when you're driving along into AC again, into 3-phase AC, and it drives an induction 3-phase motor. That's one example I saw. So it's converted twice, from AC DC, DC AC, and that uses current in itself. And don't forget, the transmission grid wastes about 8% of its power. So for every 100 kilowatt hours that are made in the power station, only 92 actually can be used at the other end. Okay, so that's a bit technical, and I do understand that. Now, one of the things about it is that the batteries are a series of usually 2-volt cells. There can be 4, depending. Like the battery of your mobile phone's about 3.7. The various different amounts, but the electric battery in the car is a number of cells hooked in series. Or you can have block cells. You can have something like the size of an ordinary car battery, where there's cobalt mixed through the mixture, the lithium ion. Doesn't really matter. They have their pros and cons. Now remember that cobalt is essential in a rechargeable battery. If you buy an ordinary battery for your flash lamp that doesn't recharge, zinc will do for the cathode. That's the casing around it. Zinc will do. There's a carbon rod in the center. But if you want to recharge that battery, it has to be cobalt. And cobalt is a very rare metal. So the thing about cobalt is that if all of the United Kingdom were to convert to electric vehicles, it would take all the world production of cobalt annually to keep them going, to keep making them and using them. It would take all the cobalt production So that doesn't seem to have occurred to governments or anything else, that if we really go all out for electric cars, we're going to run into a bottleneck of cobalt. I don't want to be too negative about them because I want to be more factual, but that is a problem. Now remember, I explained how the electric motor in an electric car uses current depending on the load. And one of the things is it has an optimum speed. And if you go above that, so the optimum speed might be 50 miles per hour. Now, in most of the data on electric cars, they use miles, strangely enough, even though a lot of them in this country are measured in kilometers. Apparently in America and everywhere else it's all miles, and nearly all the data is miles, so I have to use miles. It's very important when you're speaking to people about range and all that, that you decide whether you're dealing in kilometers or miles and convert it, because don't get confused on that. But if you a Nissan Leaf, for example, will give its longest range at 50 miles per hour. 50 miles per hour. If you drive it up to 70, while it will go faster, you will not get further on the battery, because as you increase the load, the amount of battery being drawn is greater than the mileage you get out. So as a rough example, and this is only a rough example, if you got 100 miles on a charge at 50 miles an hour, right, you will not get 100 miles at 100 miles an hour. So if you could go 100 miles an hour, you can't just speed up to 100 and get the 100 miles covered by speeding. You'll get less. You might get something maybe like 75 at 100 miles an hour, whereas at 50 miles an hour you get the 100. So as you go above a certain range, you lose range. That's because it's not linear. It doesn't give you a range equal to the amount of miles. It depends on the speed you're going at. And this is a big problem in traffic, because you'll have people behind you beeping and blowing at you, and a lot of people have this problem. You go a bit slower to get there, and they're all bypassing you out and all this sort of stuff. Just be aware that that is a thing. Now, there was the army, as I said in an earlier video, had a Citroen electric car, and its range was 160 miles, I understand, but they tested it, and it was down. They only got 100 once they used the demister, the heaters and all that on a winter's night. So be aware that all of the facilities that the car has, the wipers, the demister, the lights, the heater, big time. It's cold in a car if you have a heater. All reduces range. They all come from electricity. Whereas a petrol or diesel car generates its own heat. In fact, it wastes heat in the radiator. An electric car has to draw on the battery. And that's something that's very important to understand. And in my notion, it's a big disadvantage. So, so as I say, you'll have to stay under about 55 miles per hour or 88 kilometers per hour. And the lights and demister. Now, one thing which uses power, and I was surprised at this, is the brakes. The brakes actually, the servo assistance on an ordinary car works from the vacuum created by the engine, but on an electric car it's used by the batteries. They have to create their own vacuum, and actually braking uses power. Now, so for example, a chap I know has one of them, and he has 110 kilometers, not miles, 110 kilometers round trip to go, and he has a Nissan Leaf, and it does it, but in wintry conditions he just about gets back. It's getting a bit tricky as he gets back. Now, one of the things to remember about a battery of electric car, that it's designed that you can't fully discharge it. If you could fully discharge and get it to zero, you destroy the battery. The battery cannot take not being charged. It has to have a charge in it, so you can't take all the power out. But the point about it is you don't want to take the charge out completely. And the life of the battery is greatly increased if you keep it within between about 30% charge and about 80% charge. Not letting it go too high and not letting it go too low. That's the optimal. How you work that in your life, I don't know. That's what this particular chap gets with this Nissan Leaf anyway. And he does tell me that there is the blowing at him on the road and get out of my way and all that sort of stuff. So just to be aware of that. Now in California, the electric cars are subsidised to the tune of 55 million in the buying of them. They give you a grant. Now, I think myself, you can decide for yourself. It's very, it's a big mistake, or very foolish, to judge the value and the value of electric cars by the grants and the subsidies, because that can't go on. Now, now charging up, I just had a look at charging it. Now, you can charge them for the mains, you can charge them from a charging point, or you can charge them with a diesel generator at home. Now, I believe eventually you will have diesel generators, and you'll have companies who will have a van with a diesel generator in it you'll be able to call them out, and they'll give you a charge to get you home. I think there's money to be made in that, and that defeats the whole purpose, of course, of the electric car if you have to charge it with a diesel generator. But all generation uses fuel. They tell you wind, it can do a bit of it. It's very minor. The contribution of wind energy to the electricity grid is quite small. It's only a few percentage points. Right, you'll get a good windy day, but there's a limit on how much wind you can let into the system. You can't allow any more than 60 to 63% of wind energy into the system. You always have to have fossil fuel there, even in a windy night. But then, a lot of times, you have calm weather and you have no wind. So you have to have a grid system with a fossil fuel generation that's capable of working on a dark, cold, calm night. You have to have that. And that's another day's work. We'll look at that again. So charging it up. Now, with the mains here, if I were to charge my car here, there's a lot of debate about this. I pay 26 cents per kilowatt hour per unit. Night, day, irrespective. There is nighttime charging, but then a lot of people find it doesn't really work out too well. You have to leave your machines working all night when you're having to sleep and all that. So that's what I'd be paying, 26 cents a night. A kilowatt hour, right? Charge up. Now, so I see there on the internet, Electric Highway is going to increase their prices from 30 to 39. That's the street parking. The street parking, okay? And there's Ionity, which has increased its prices to 79 right now, this time of the year in 2020. So that'd leave it quite expensive. Now, I worked out a Nissan Leaf will do 3.5 miles on a kilowatt hour on a unit. A Tesla, the big fancy one, will do 2 miles per kilowatt hour. And I've submitted this to there was a recent public consultation. It's over now on this, and I made a submission. And so if you look at the Tesla, the Leaf, you'll get it's 7.5 euros to go 100 miles, whereas with a petrol or a diesel car, an efficient diesel of the same size, it's 16.6. Now remember, most of that is tax and excise duty, which the government will eventually have to recoup. So the Tesla will cost you 13 euros, and with the diesel car, it'll cost you 21. So again, it is a bit cheaper. Now, so with this price here of 79 Ionity, that cost will be 22 and 39. So if you're charging with Ionity from now on, it'll be more expensive to run an electric car. The ESB runs them here. I'm not too sure what the rate is here, but you can check that out yourself. So there's the problem for the government of the loss of excise duty. Where are they going to get the excise duty and the VAT that they get on fossil fuel? And will they clamp it on these? And there is evidence that originally they were free. You didn't have to pay at all, and then they put a charge on them, and that's normal. I mean, anyone that falls for that, they think that they're cheaper because the government subsidises them. The government has to get its money somewhere, and eventually, if they got everyone over to electric, they'd put the price up. Now, the thing about it is that's only a little bit of an introduction for you, because I'll be having a wee bit more of a look at it in due course. Certainly, I can say that I know people who have them. They're not all they're cracked up to be. They are certainly not all they're cracked up to be. But I don't want to be too negative about them as well, because one of the problems we will have, if everyone goes over for electric cars, where is the power going to come from? where does the electricity come from, and how will the housing and the distribution of electricity be adopted for it? And there was a public consultation on that, and I made a submission. So right for now, if you're deciding to go in an electric car, I didn't deal with the capital cost, I didn't deal with the battery life, I didn't deal with any of that, except that it is possible to damage the battery by misusing it. However, they have software in them to stop you discharging it completely. They work, they do work. And I drove a Nissan Leaf. It's a nice car to drive. It is a lovely car to drive. I would drive it no problem for tipping about. But it's, you must remember that the power has to come from somewhere. In Ireland, the people mostly believe it comes from a hole in the wall and it doesn't have to have any emissions. And the Irish government advertises its cars and electric cars as zero emissions, and some of them call them zero emissions. But of course, that's Ireland. We believe in leprechauns and fairies here as well. We believe they're green, and we'd be looking a little more at this. I don't want to knock them too much, but just be aware for your own practical use. You're caught with range. People have to have employment to suit them, and what happens to them when they get older, we'll be looking at all that. There's nothing, they're made available because battery technology has improved. That's why the mobile phone, you can get a small little mobile phone. It's the battery that delayed its development, the lithium-ion battery. And as I say, the cobalt is the biggest problem. There's a good supply of lithium-ion, and unfortunately they're not very green from this respect, in that a lot of children and child labour is being used in the Congo. And they're getting bad press over that. But for now, anyway, I haven't given you a full opinion. I'm letting people alone, but they're so expensive anyway to buy, and they're so expensive to maintain, and the second-hand value is open to question, and changing the batteries and all that is an issue, and we'll look at that at a later stage. I haven't given you an answer, but just there's some of the things that currently the fuel is cheaper, but will that last? Who will pay the road tax and all that? I think eventually you're going to see that they'll eventually be trying to force you to use electric cars, because they'll ban the diesel and the petrol ones. But our Fine Gael government, who's extreme left-wing Green party, has lost badly in a general election recently, and it isn't winning too well. I mean, in the UK election, the Green party only got 1 out of 600 and something seats. One MP. Here we got 12 in the last election, but again, as I say, the Irish do believe in fairies and fairy dust and all that sort of stuff, so I wouldn't pay too much heed to them. There are problems with a diesel and petrol car as well. They can break, and when they get older, parts break and they can be a scourge. And they're designing diesel and petrol cars now with a lot of software in them, with brains and all kinds of stuff, and that can be an awful problem. They really want to put people off, and I think myself, I suspect that the EU and the government here are telling car makers to push us over to electric cars. They just don't want us with cars at all. But that's another day's work. We'll see how it goes, and we'll be back to you after a while. So thanks very much for looking in, right?